Okay, so we're just going over the front part of 8b.1, okay? So these ones, it says tell whether the ordered pair is the solution of the system, state yes or no. So all you're doing here is we're just plugging in for x and for y. Okay, so for both equations, this is your x, and for both equations, this is your y. You have to plug into both equations to see if it works, okay? If it doesn't work for one, you can be done, but you have to check both of them, okay? Excuse me. So here, so we're just going to do one equation at a time, okay? So I'm going to start with this one. So x minus y. So your x here is 2, okay? 2 minus, anytime you plug in something, you have to put it in parentheses. 2 minus negative 3 equals 5. If you have negative, negative, it turns to positive. So 2 plus 3 equals 5. 5 is equal to 5. So yes, this equation works. Once you're done with one, you have to check the other one. Okay, so we're going to plug in again. So 3, wherever you see the x, you're going to multiply, or you're going to plug in a 2, plus 4, wherever you see a y, you're going to plug in the negative 3. And we're just going to check this. Okay, equals negative 6. So 3 times 2 gives you 6. 4 times negative 3 is negative 12, equals negative 6. 6 minus 12 is negative 6, equals negative 6. That's a true equation, so yes. So is this ordered pair a solution? Since they both work, this is yes. Basically what this means is if I drew both of these equations on a graph, if I graphed them, they would both have this point on them. So they would cross at that one point. Okay, next one. Same thing, we're just going to plug in. So I'm going to plug in this for x, this is for y. So for your first equation, you would get negative 7 equal to 2 times negative 2 minus 3, and you just have to work this out. Negative 7 equals 2 times negative 2 is negative 4 minus 3. Negative 7 is equal to negative minus negative, keeps negative. Is negative 7 equal to negative 7? Yes. So your first equation works. If the first one works, you still have to check the second one. Same thing here. So we're going to plug in negative 7 for y. Plug in negative 2 for x. So negative 7 equal to negative 8 plus 1. If you have a positive and negative, remember, same signs add and keep. Different signs mean subtract. So the difference between 8 and 1 is 7. Take the sign of the larger one, which is negative. Since that one works, and they both work, is this a solution? Yes, because it's on both of the lines. Keep checking these. Okay, we're, again, going to plug in for x and for y. So x is 0 plus 2 times negative 2 equals negative 4. The 0 just goes away. So is negative 4 equal to negative 4? Yes, that first one works. Then check the second one. Negative times 0 minus 3 times negative 2 equals 6. What's negative 0? Still just 0. Is 0 plus 6 equal to 6? Yes, it is. That one works. So is this a solution? Yes. Okay. Keep trying. X and y. Okay, for the first one, if I plug in right here, 3 times 5 minus 5 times 1 is equal to 12. So 3 times 5 is 15. Minus 5 is equal to 12. 15 minus 5 is 10. Is 10 equal to 12? No. Since the first one doesn't work, you do not have to check the second one. This is automatically going to be a no. Okay, if one doesn't work, you don't have to check the other one. Anybody have questions so far? So this is just plugging things in. Okay. Here, same thing. X minus 2y equals 1, so we're going to plug in. So your x is 3 minus 2 times 2 is equal to 1. 3 minus 4 is equal to 1. What's 3 minus 4? Negative 1. Is negative 1 equal to positive 1? No. So since the first one didn't work, you don't even have to check the second one. This is the no. And then same thing here. Start with your first one. And it doesn't really matter which one you start with. You could start with the second one. Does not matter. So if we plug in, your x is 4 minus -1 equals 5. So 4 negative means plus 1. So 5 equals 5. That one works. So now you have to check the second one. 3 times 4 plus 4 times -1 is equal to -6. 3 times 4 is 12. 4 times -1 is -4. Is equal to -6. So is 8, equal to -6? No. So since one of them doesn't work, your overall answer is no. Okay, so even if one works and one doesn't, the answer is still no. Okay, so on these you should have had yes, 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 no, no, no. Anyone have questions on how I did those? Legit questions, or are you guys just saying that? Okay, on the graphing, okay, graph the following systems and state the solution. We're trying to figure out where do two graphs cross. Okay, before you can graph things, what form do they need to be in? Y equals mx plus b. Does anyone remember what's that called? What form is that called? Slope-intercept form. Okay, so I'm going to graph these in 2 different colors. Okay, we're going to do red and green. Now, when we start these, remember, you always want to start with the B. The B tells you where to begin. What's the technical math term for the B? The y-intercept. Okay, but when we're graphing, B tells you where to begin. M tells you how to move, but what's the technical math term for M? M is called the slope. Okay, but it's going to tell us how to move. So here, this one's already in the right form. If we start at up 2, so that means y at 2. Then to move, what's the slope of this equation? -2 over 1. A little bigger for you. Remember, if you haven't done this yet, you should be filling it in. So -2 over 1. So down 2 over 1. Down 2 over 1. I'm going to make 3 dots just because I want to have really nice straight lines. I want them to be perfect. You could just make 2 though. Okay, you don't have to make three dots to make your straight line. Then for this one, what's the y-intercept? Where's my beginning point? -2. At -2. And what's my slope of this equation? -2 over 1. Okay, so again, we could go down 2 over 1. Down 2 over 1. Again, I'm just making 3 dots because I want to make really nice straight lines. Where do these two cross each other? What if they cross like way, way, way up here? How can you tell that these are never going to cross each other?
Because
these are parallel, okay? You know that these two are parallel because they have the exact same slope, okay? So if 2 lines have the exact same slope, it means they are parallel. Parallel lines will never, ever, ever cross. So the intersection here is actually no solution, okay? And you know that things are no solution if you have the exact same parallel lines. Okay, so if you have 2 parallel lines. I want you guys to try this one. Okay, try number 8 on your own real quick. You try to graph number 8 and tell me where they cross. Okay, no problem. Thank you. Who wants to take Cassie's things to the office?
I'll do it.
Someone, not you.
Jordan's up first.
Okay, Jordan can take it. Just take Cassie's things to the Rayburn Health Office things.
Taking your chair.
Health Office, yeah. So the nurse's office at Rayburn.
Jordan, taking your chair.
Okay, for number 8. Listen, for number 8, again, we're going to graph these. Okay, so what is the y-intercept for the first line on number 8? Y-intercept is at -1. So start, your beginning point is -1. Then how do I move? What's the slope?
Negative 1 over 2.
-1 over 2. So we always go down 1 over 2. Okay, down 1 over 2. Once you have at least 2 dots, and it could be more, it's okay. Once you have at least 2 dots, and it could be more, draw your line. Okay. Then, for the green line, what's my beginning point? What's my y-intercept? At -4. So down 1, 2, 3, 4. How do I move to get to my next point?
Down 1.
Up 1.
Up 1 over 4. 1, 2, 3, 4. Now, since I made a couple of dots, hopefully you should see exactly where these intersect. And these should be intersecting all of the ones that we're giving you on what are called lattice points. So they're going to be nice numbers, okay? They're not going to be like in between or anything like that. So what is the intersection point? What would you say is the solution to this system?
4 negative.
Over 1, 2, 3, 4, down 1, 2, 3. So your solution would be 4, -3. Alright, it's just where do these two cross? Anyone have questions so far? So it's all about just graphing. Okay, so figuring out where the two lines cross. On number 9, we're going to do the exact same thing. Okay, before you can graph, make sure that these are already in slope-intercept form or y equals mx plus b form, and these already are, so they're good. So for the first one, what's the y-intercept? Where would you begin your graph? At -4. So down 1, 2, 3, 4. How do you move? What's the slope for this equation?
3 up and 1.
Up 3 over 1. Okay, if it helps you, you can always write this as a fraction right there. Up 3 over 1. Okay, and I just, like I said earlier, I like to make more than just 2 dots so that I'll make sure that my line is nice and straight. You don't have to, though. You don't have to use a ruler, but I have plenty of them if you'd like to borrow them. How about for the green line? Where would my starting point be? Where's my y-intercept? At up 3. Up 3, and then to move, how do I get to the next point?
Down 1.
-1, so down 1 over 2. Hopefully you can see exactly where those are going to cross. Okay, then label where they cross or where they intersect. What point is this? Right here. Over 2, up 2. By the way, make sure that you're putting these in parentheses because otherwise it's technically wrong. Okay, a point should be in parentheses. Number 10 is just a little bit different. Okay, for the y equals -1. What's missing there in the equation? It's supposed to be y equals mx plus b. Is there an x in that equation? No. So this is y equals, what's attached to the x if it's just missing? A 0. 0x minus 1. So if I was to write that in slope-intercept form, it would be y equals 0x minus 1. So what's your y-intercept here? The -1. How do I move to get to the next point?
Oh, you didn't move just
0 over 1. Didn't that say this?
Up 0 over 1. Literally. Up 0 over 1. I remember we've done y equals and x equals lines before. Y equals lines are flat lined, okay? They're like, why are you dead? Or you can think of it as the slope of being 0. So you're not, like if you were walking on a hill, you're putting in 0 effort, okay? You're walking at 0. That is what a y equals line looks like. It's a flat line, okay? For the green line, where would you start your graph? What's your first point? Your y-intercept? Up 4. So up 1, 2, 3, 4. And how do you move to get to the next point?
to go
Your slope is
5
down 5 over 2. Down 5 over 2. Connect your dots with the line. And we want to figure out where these two lines cross. So what is the point of intersection here? Over 2, down 1. So over 2, -1. to -1 would be your point of intersection. Almost done. We have 2 more. Okay. Here, y equals 3x minus 1. That one's fine. But what's wrong with this other equation? It's not in y equals mx plus b form. How could I get it there? If I want to get y completely by itself, how would I get y by itself?
Add 3 to it.
You want to move the 3x. So how do I move it to the other side?
You add 3x.
Add 3x to both sides. Okay, remember, you have to be fair to both sides. So if you rewrite this, we're going to get y equals, which part should go first? The 1 or the 3x?
3x.
The 3x. You always want to write the 3 or the x part first. Now I should be able to graph this. Okay? So here, for my red line, what's my starting point? What's my y-intercept? -1. And how do I get to my next point?
Up
3 over 1.
Up 3 over 1. Okay, connect your dots. You can make more points if you want to, but I'm just going to go with 2. So up 3 over 1. Now that I've rearranged this green line, what's its starting point? Where's its y-intercept?
1.
At +1, so up 1. And how do I get to the next point? What's its slope?
3. Up 3.
Up 3 over 1. Okay, connect these. This is why using a ruler is really good, because it gets you a little more exact lines. Where do these 2 lines intersect?
Never.
Never.
They have the same slope.
But what if they intersect way up here? How can you be absolutely sure that they're never going to
They have the
intersect?
same slope.
They have the exact same slope. Okay, if you look at the slope here, this one has a slope of 3. This one also has a slope of 3. So for each line, they're both, from each point, they're going to go up 3 over 1, up 3 over 1. If lines have the exact same slope, what are they called to each other? They're parallel. Okay, and parallel slopes, or excuse me, parallel lines never cross. So what is the solution for this systems of equations?
No.
There is no solution. Okay? They will never cross each other. That is a no solution. Last one here. First off, what's wrong with this first equation? It's written backwards, okay? So we're going to take this one and I'm just going to rewrite it. So y equals 6 minus 4x. What's wrong with it? The x part's not written first. If I want to rearrange this, what's the x part? What's attached to the x? A -4x. And then what's the sign on the 6?
Plus 6.
Plus 6. Okay, so now that it's rearranged, now I can draw it, or graph it. What's its starting point? What's its y-intercept?
6.
+6. So up 1, 2, 3, 4, 5, 6. How do I move to get to my next point? What's its slope? What's the slope of this line? -4. So that means go down 4 over 1. Once you have at least 2 points, you can connect them together with a straight line. It's nice if you have more than 2, but you only have to have 2. And then the green line, what's its starting point or its y-intercept?
6.
Up 6. So up 1, 2, 3, 4, 5, 6. So they have the same y-intercept. What's its slope?
The same.
The same. Down 4 over 1. What happens if I have the exact same line? Where do they cross? They don't cross anywhere?
They cross everywhere. All points on the graph.
They cross everywhere. Okay, they cross at this point and this point and this point. Okay. Is there just one intersection point or one crossing point? How many are there?
3. A lot.
A lot. Can I count them all? No, you can't count them all, okay? This is what's called infinite solutions. Infinite solutions. Okay, that basically means I cannot count all the crossing points. Okay, they cross everywhere, so that's a special case called infinite solutions. Okay, there's going to be 2 special cases that you might see when you're dealing with these. The first one is no solution. How do you know if something is going to be no solution?
Because it's exactly the same slope.
If they're parallel lines and you know things are parallel lines if they have the exact same slope but different y-intercepts. You can also have infinite solutions. Infinite solutions means they will always be crossing. Okay, do we have any questions on how to do that? Okay, for homework today, you guys are going to be working on the second portion of your homework from last night. Okay, so you should have already done this. But, unfortunately, on your homework, you do not have grids. Okay, so what you need to do is you need to take a pencil or a pen or something like that. You need to draw in the grids. I'm sorry that it's difficult, but you need to do it. Okay, you need to draw in the grids. I'm sorry that they are not on there. If you've already done it, then good for you. You don't have homework for tonight. If you did not do it, then you have 8 problems of homework, and hopefully it will be a little bit easier since I showed you how to do it. Do we have any questions?
Is your break teacher long ago?
Yes.
Oh, dang.